So quick show of hands or in chat, there are host controls, and I can say allow emojis and reactions and things. Just everybody go into chat. How many of you admit to using the acronym SSL today? Anybody? Yeah. So SSL, everybody uses SSL. Here's the funny thing. SSL has been deprecated for 15 years. Nobody should ever use it, but we apply a do what I mean filter because it's supposed to be TLS. I'll explain that and a lot of other stuff in this workshop. So this is designed to be hands-on. One of the things that you'll need if you don't have it right now ready, it was in the abstract, but things happen, is you need a Linux server of some Debian, Ubuntu, even a Kali Linux would work. You just have to have access to it. So right here, I have a brand new, as in I installed it 2 hours ago from scratch, Ubuntu server, and it's there. It is ready to go, and I will be logging into it to do stuff. Yeah, I got you, Derek. The only real reason to use the acronym SSL is because everybody else uses it, but it's TLS. Did I install the latest version live? I grabbed the ISO. So it's Ubuntu server from the ISO as a regular install. So it's not like the live CD or anything like that. I have a cheat sheet. This is good. If you go here, I will put this into chat. Oh, what could go wrong? Smith has to remember how to use the cut and paste. Okay. There's a GitHub repo for you. If you want to grab it, you can just grab everything locally. You just go here, code, and you can grab it with HTTPS, copy that, and then just git clone. Here you go. It's pretty straightforward. But that'll give you resources, or you could grab it with SSH if you have a GitHub account, or you could just click here and load this up in the browser. You can go there. You can view it all. It's pretty boring. It just has 2 resources that you will want. Okay. First resource is you've got this readme.md that just says class slides and notes. Nothing interesting there. Hit notes.md, and that will give you my wonderful list of acronyms, because the certificates have tons of acronyms. You can grab everything there. I also have command line commands. So when we get to the part where we're doing stuff, you can just cut, paste. You can do cut, paste, command line wizardry, or just so you can look and make sure you spell stuff right. So that's there. The other thing that's there, if you go out to the top of this, is there's a PDF here. Oddly enough, that's a PDF version of my slides. So you can follow along at home. See, there's me, handsome. But you can follow along at home. You have access to it all. You can cheat and go ahead, right? Get ahead of ourselves, but that's okay. But the big one that you want is you'll just want to have the notes.md up and open, right? Because that'll tell you everything you need to know. Cool? We good, folks? Okay. And the big one that's going to be the big surprise is going to be some kind of an Ubuntu, Debian, Kali, Mint, anything that's app-based, that's a Linux. It'll be there and it'll work for you. All the software, all of the resources are common on everything, 0 problems. So this takes us to what we're talking about today. We are talking TLS, so transport layer security, and certificates, or X509 certificates. A little bit about me. In my normal job, I am the field CTO for a company called Verkara. We just got bought by this company called DigiCert, who is huge in the certificate space. They're a certificate authority. So they sign certificates, and we'll talk ad nauseum about that. Normally, for the past 2 years, I've been dealing with a lot of DNS stuff. So domain name system, DDoS mitigation, web proxies, web application firewall, bunch of other stuff like that in there. And I have lots of conversations about TLS certificates for various reasons. The biggest one being they're confusing. And they're kind of black magic. And so that's why I put this workshop together, is building out skills, because TLS and certificates are very fundamental. And so that helps us to adapt all these other things like setting up an email server, setting up a web server, understanding why my stuff doesn't work and being able to troubleshoot it. A bunch of that stuff goes back to TLS certificates. Okay. I have 4 sections of this. We'll probably get to section 3 and then we'll be done for the day because we have 2 hours for this, but we'll get there. Okay. First section here, we just terms, right? Terms, acronyms. Use this MD that I have. So Markdown, which is MD, but I've got this list of acronyms here. We'll go through and explain most of these, but keep this up and you can actually flip back and forth. And when you hit an acronym you don't know, you can go look and see what it is. On section 2, we'll actually create our own CA. We'll create our own certificates. We'll deploy it. Exercise 3 is SSL Labs, which is it's a scanner for TLS settings. And yes, they still call it SSL Labs. And then section 4, the screen is on the terminal. Are you supposed to? So there. This is slides. Cool. You guys can see that? Like you should see agenda. If you don't, let me know. We'll backtrack and I'll unmess myself up. Okay. And then 4, we can talk Let's Encrypt, non-TLS stuff, all of those things. Okay. You should see a little bit of a terminal here, but that guy just hides because I'm sharing the entire screen. So here. Okay. So let's get into this, right? Cryptographic terms. So why is it interesting to study TLS and PKI? PKI is public key infrastructure, which is a big, lofty name for the hierarchy of certificates, okay? Where you have a public key, you have a private key. All the public keys are posted out there. You can take a look at those. You give those to clients. Public key ends up on them, both the public and the private key end up on the server. The server identifies itself using the using that certificate, which has the public key in it. TLS itself, transport layer security, used to be SSL, now it's TLS. It is complicated and it's a lot of acronyms. It's a lot of different, like discrete individual settings. And it is absolutely the easiest way in the IT world to mess stuff up. And it happens all the time. We all laugh at each other when it happens. Websites have certificates that expire and you go to the website and you're like, their certificate expired yesterday. That's funny. And then if you know the administrators over there, you tease them like, hey, you guys can't manage it. Because everybody has problems managing these things. It's a evolution in standards. So as the standards change and cryptographers come out and they break particular versions or algorithms, or they say this particular use this way is no longer secure, then you have to go upgrade your stuff or change your configuration settings. So it's a slow and steady march. And it's so eclectic that if you don't do it every day, like even me, and I've been doing this for 30 years, I still need cheat sheets to make sure that I get all the steps in the right order and that I get everything that I need to, because it's just easy to make mistakes when you don't do it constantly. And browsers use TLS by default. So they made a change a year or 2 ago where web browsers now, instead of checking the HTTP version of a site, they'll check HTTPS first. And that whole kind of movement was called SSL everywhere, SSL again, but it's TLS everywhere. The browsers just finally switched over and started checking the TLS version of the website first. And so what that means is a lot of websites that 2 years ago or before would work and they just used HTTP, now suddenly they don't show up in the browser. The browser throws warnings that says, hey, this website is drastically insecure. Why do you want to go there? Simply because they don't have TLS there. Vulnerability scanners love to find problems because it's kind of this change and you have to go take algorithms and cipher suites and different handshakes and all that stuff. As that moves on over time, vulnerability scanners find it and you go, okay, what does that mean? You have to go solve it. It's good at building a cryptographic system. So there's a utility that we'll use called OpenSSL. It's a library. So there's OpenSSL library, again, SSL. There are command line programs that allow you to use OpenSSL. It's got different modules, a bunch of different modules, but they're really raw. It's like you're using the library, different modules of the library to do something, but it's not like the whole process is automated to just do it, do what I mean. You have to go in and write each command line, and it has these weird flags, and the like syntax for it is a little bit weird. It's just not the most user-friendly experience, but you can use it for a bunch of things. So I worked on a project a long time ago where I built the signature standard for boarding passes. So when you fly on an airplane, your ticket has a barcode on it. I wrote the signature standard for that as a contractor for TSA. Well, that I sat down and built examples step by step on how to get to a signed boarding pass. And I used OpenSSL and the Linux command line in order to say at each step, here was the command that you use, here was the output of it, here's what it looks like, so that people could test their own software and that they could verify that their software actually worked. So it's really good for learning about basic cryptography and implementation of cryptography by accessing the algorithms almost directly. You're just like one step removed from it. And then acronyms are fun, and by fun I mean not at all. So yeah, there's me. I work for this little internet startup called Akamai. Worked there for 10 years. I spent 3 years of it explaining how certificates get created, how they get loaded up on the CDN, how all that verification works, how they set up their basically how CDNs work, how the certificate management works on a content delivery network, which has a lot of websites on it. I've worked through a lot of different vulnerabilities, and my God, the sky is ending. Let's go fix TLS yet again. Incidents, I've done all those. Yeah, I've been around there, done stuff because I'm an old guy. I just act like I'm 12. Okay. Question here from Dalton in chat that I want to address is everything needed to complete the lab on the GitHub slides? Yes, it's all there. Yeah, there's not like task conditions and standards for labs, but you can go in and look and say, oh, here's an activity, go figure out how to do it. Okay. If it's not there, drop me a message. I'll help get you through it. Okay. It could be my documentation is not complete. Not the first time I've ever heard that. Okay. Go back to CISSP, Security Plus type stuff. There are two types of encryption algorithms or ciphers. Okay. You have symmetric ciphers and you have asymmetric. And this works into TLS in different ways. Symmetric ciphers, I have a key, you have a key, I encrypt stuff, give it to you, you decrypt it using that key. Really, really fast, or relatively fast. Easy to understand, right? Because mathematically it's simpler. But key distribution, so you having the same key that I have to encrypt and decrypt is a hard problem to solve with engineering. Okay? Asymmetric, you take that key and you break it into two pieces, and you have a public key that I can give to you, and I have a private key. So you can take things and encrypt it using my public key. I take my private key and decrypt it. Okay. So that makes it a one-way or a two-way, like a two-way functionality. So if you have a public and private key pair, I have a public and private key pair, we can create messages only for each other and send that back and forth. And these are good for multiple things, right? So asymmetric is a slower, it uses more resources, but it's easier for key distribution. And so when they built out SSL and then TLS, they took this into consideration. And so they used the right algorithms in the right places. What this means for us is that symmetric cryptography is really good for encrypting the communication between your browser and a web server. but it's really bad for like determining who we are and getting like creating that key that we both have, because you're just some rando on the internet that I've never met before. Where asymmetric cryptography is really good at identifying who that remote server is that you're talking to, maybe identifying your browser, right? Who is the server actually talking to, but also for verifying that that server is the right server because they have a certificate that's signed. So digital signatures use asymmetric cryptography. Question from chat. Am I talking on post-quantum? I am not. I am not the guy for post-quantum cryptography. I can absolutely guarantee that. Okay. All right. Hashing algorithms. Hashing algorithms are things like MD5, and you'll see these down here, right? So MD5, SHA-256, we use these all the time, every day. What they are is you take a file or a string of characters or a binary of some kind of input, and you basically add all these up and keep adding them up and then adding them up and reduce it down into something called a message digest. Okay. And you do this all the time. When you go to VirusTotal, you say, oh, here's a file and I don't know if it's malware or not. So you make an MD5 sum of it. And the actual command is MD5 sum. And you go take that hash value. Sometimes they're called a, what are they called? Either a hash value or a checksum. Sometimes there are a couple other like names that they have. Message digest is officially what it is. And you load that up to VirusTotal and it tells you, oh, is it a virus or not? Did somebody already submit it? Is it in the database? And so it's really good for identifying that, has this file changed or is this file the same as some other file? You hash one, you hash the other, you compare the hash values. Okay. And so we use that a lot, but you use hashing algorithms in digital signatures. So what I do is I say, here's a document and I want to sign this document. So what I do is I make a hash of it and I sign that using my private key. So anybody else that's out there can take my public key, decrypt that signature and say, yes, Mike signed this because I have his public key and I decrypted the signature and I did the MD5 sum, or I did the hash on that file, and the hash that I got matched the decrypted hash. And that's how you validate a signature. Okay. And I actually have this here. In TLS land, we call it a message authentication code, or a MAC. We call it MAC. It's basically a signature. Okay. And you can use that on individual packets. What we use it for in the X509, the certificate world, is you have a signature, you create a certificate, it's signed by a certificate authority so that you can verify, did that actually come, was that signed by the certificate authority? Okay. And a lot of times you'll have a chain. We'll talk about chaining. Okay. Digital signature is a MAC. Okay. And they actually call it an HMAC, which is for a particular usage of a MAC. Why? It's a hash message authentication code or hash-based message authentication code. You ask 10 people, you'll get 15 different answers. Anything that I missed there? Yeah, just remember asymmetric encryption. So you sign it with your private key, you verify with the public key, and you're really just encrypting that hash value. Okay. Key exchange in TLS. So you remember that symmetric, asymmetric ciphers. So when we have a conversation, we'll use a symmetric cipher because it's faster. Okay. And it uses less CPU. But we don't know, we don't have an exchanged key between the two of us that we can use for that symmetric encryption. So what we'll do is use it's protocol. It's not like a network protocol. It's a process that's a protocol, but it's called Diffie-Hellman. Okay? And it's named after the two folks who created it. And what it is just a way for a web browser and a web server to negotiate by sending some messages back and forth to create this encryption key that then they use for the rest of their traffic. Okay? And so it's like, hey, I want to talk to you. Hey, I want to talk to you. Hey, here's a message. Hey, I altered it and I send it back to you. I know the secret that I used to create it, so I can extract your secret from it. And then we have a key and we start talking. Don't focus too much on that from the implementation side. Just remember that Diffie-Hellman, and there are different variations of it. Some are more secure than others. It's evolved over time. But it's that handshake in order to create that session key that we then use for encryption. There's a concept, and this one has been around for a little while. It's pretty much standard out in production now, which is good, which is this perfect forward secrecy. Back in the old days, your browser and the server would negotiate a session key, and then they would keep reusing that conversation after conversation after conversation. So the problem is, if at some point in the future, somebody got that session key, they could come back and decrypt all of the conversations you had before. So perfect forward secrecy, which is a big lofty name, basically means for every conversation, we do the handshake and we make a new session key. That way, if somebody compromises that key, they can only decrypt that one conversation that we had. And then that takes us to the last one, which is X509 certificates. X509 is the standard that's it's like a data schema for certificates. And it basically says, if you take a private key, and down here I've got it, if you take a private key, private key itself is just a string of pseudo-random bits. It doesn't have any kind of metadata around it. So let's add metadata or a wrapper, not like Snoop Dogg, but more like a candy bar, or an envelope. Let's add that around the outside and have information like, who does it belong to? What host name is that certificate for? And what was the serial number? So that if we see this again, we can test to make sure that it's not the same one. Who issued it? Who signed it? What's the expiration date on it? Okay. And so you have all that data in there that you can look at. And that certificate is signed by somebody called a certificate authority. And we'll talk a lot about certificate authority. So around the outside, yes, and I do appreciate the M&M reference. Now, that takes us to a demo. So everybody pull up a web browser. We're going to go to this little website called google.com. Cool? Thumbs up, google.com. Pretty easy. I hope you remember it. And if you're on Chrome, you can hit this up here. You've got this view site information. Click on that thing, and you get like a couple things like cookies and site data. Da, 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 da. Up here, it says connection is secure, and you just want to click on that thing. And it says, oh, it's secure. And down here, it says certificate is valid. You want to hit that thing. And that opens up a dialog. Now, that dialog is pretty small to see, and I don't think I can make it bigger, so you're going to have to do your own. But what this is details about the certificate, okay? And you remember back here, if I go to my slides, right, I've got some of these listed. So I've got O is the organization name and address. So if we look here, we've got organization, and that's right there. And boom, they didn't actually list an organization because it's Google. They don't care. You do have a CN, which is common name, or sometimes CN is canonical name. But that is, what's the regular, like, what's the name of the organization or the website? Excuse me. What fully qualified domain names is that valid for? In this case, we've got a dot or a star dot, google.com. But this certificate is valid for any host name or subdomain host name in the google.com domain. Normally, your organization would be like Google LLC or Google Incorporated. That's normally the organization. The organizational unit would be something like Google Search or Google Web Team. You have, this is issued to, and I can't highlight it. Down here, you have issued by, which is who signed it, okay? I mean, in this case, it was signed by WR2. The organization is Google Trust Services. So that's Google's certification authority. They didn't have an organization unit that was part of the certificate. The issued on is the day that it was created. Expires is when's the expiration date? You usually set an expiration date that's shorter. Like back in the old days, we made certificates for 10 years, which is a problem because if somebody compromises that certificate or the key with it, then it's good for 10 years. Somebody can impersonate you for 10 years. So nowadays, best practice is like less than a year. And a lot of places like Google themselves, they issue certificates for 3 months. Okay, Let's Encrypt, which is a public CA, gives you a certificate for 90 days. And then down here, you've got fingerprints. So this is SHA-256 hash algorithm. Here's the entire certificate. Here's a fingerprint, just the hash value. And then here's the public key, which is if you take the public key that's in the certificate and hash it, that's the hash of that. And you also have the detail section here. And this is, sometimes I can't stretch it to make it bigger, but this has all of the different things are here. This is the full details where the general information is just the parts that are relevant usually for you. I usually go to the details. There is one thing in here, which is extended key usage, certificate key usage. That is, what can you use this for? And in this case, they can use it for signing things and they can use it for critical use. There's one that's like, can you use it? Is this a CA certificate? They'll have that listed there. They'll have something that's like CRL, which is where, if it's revoked, where does the CA list it? A bunch of stuff in there. You can start messing around with it. We won't worry about that for today. You can also export it so you can save it locally for other purposes. So that's that. Everybody got it? Thumbs up. Cool. You can see certs in your browser, see what they are, easy stuff, right? Like the software does it for you. Now, TLS itself is in evolution. So there was SSL v1, nobody used it ever. It was in academia. SSL v2, which was like old school. The internet went squawk-ree-raw, boing, boing, boing. Like it was before the .com era. SSL v3 was around for a long, long time. It was around for like 15 years. And then it was deprecated. It had some problems. It didn't support all of the ciphers. It just needed an update. And there was some political, like, everything, all the standards bodies are political, and it's people's and personalities and what organization is in charge. So they went through kind of a change there. And then they changed it from SSL, which I think SSL might have been somebody's trademark. And they're like, fine, we were not going to play with that. And so they turned it into TLS, Transport Layer Security. SSL was Secure Sockets Layer. And there's some basic differences. The big one protocol-wise is SSL, specifically when you connect, you just start doing your key exchange and negotiating a session. TLS, you make a TCP connection, and then you say, oh, start TLS. It's in plain text. Start TLS, and then you start your negotiation. So that came up. TLS, and so they created TLS 1, and then 1.1, 1.2. It keeps marching over time. Today, the right answer is TLS 1.2 and TLS 1.3 if you can do it, okay? So all the rest of these, everything from 1.1 and earlier, that's been deprecated over time. The standard keeps marching forward, okay? Other weirdnesses, other stuff that you see out there. So Google themselves, remember this, here, certificate, they actually use a wildcard certificate. That's what a star dot is, right? Which is basically anything.google.com, the certificate is valid for it. Okay, so that's a wildcard. There's another one out there called a subject alternate names, and this certificate doesn't have it. You can go into the details. it might not have it. It's usually in the extensions. Subject alter. Oh, they do. Cool. So subject alternative names is what are the other host names or fully qualified domain names that this certificate applies to? And you can see, oh, they still have Google. They still have the wildcard for google.com. They've got appengine.bdn. origintest.bdn.dev. A bunch of different, these are called country code TLDs. So, country code top level domains for DNS. So .au, .co, .uk, .mx, all of those. If you're doing a penetration test and you go to a web server, view the certificates, look for the subject alternative names because it lists a bunch of other websites that you can go attack because they're all using that same certificate. They're all probably on the same server. It's a good reconnaissance step, right? And that's why I said, ooh, why? Because I've got like origintest.bdn.dev. Interesting. Okay, probably .dev is, well, that might or might not work, but I'd at least go check it out, especially when it's like test.google.com or website deployment test or QA. Whatever. You'll find it on the subject alternative names. SNI is this weird thing which makes the web today work. Early versions of SSL were paranoid, and they wouldn't give you the certificate until you negotiated. So what that meant was you would have one service port, one certificate, one IP address. Okay. SNI, what happens is you make the connection, you make a TCP connection. You say start TLS and your browser says, I would like to talk to google.com. That allows you to have multiple TLS certificates on that web server so that it scales out, right? You can have multiple websites on one server, one service port, which is really the big thing, one IP address. You can have multiple websites there with different certificates, and the client will actually tell you which server it's going to talk to, so that way you can give it the right certificate. Okay, that's SNI. SNI keeps us from having the other DNS, which is does not scale. That's how you get TLS to scale out, is SNI. HTTP strict transport security. I love the acronyms. HSTS is an HTTP header that says from now on, henceforth and forevermore until this time, it gives you a time in seconds. Henceforth and forevermore until this timer expires, please use the TLS version of this website instead of the HTTP version. Easy stuff, right? Use TLS from here on out, and it's in the HTTP header. Okay. A CRL, also called CRIL, is when a CA signs a certificate, it publishes a list. And that list is all of the certificates that it says, nope, I'm going to delete you. It publishes that so that when your browser goes and checks the certificate, it can also check the CRL, even though the certificate hasn't expired yet. The CRL will list if that certificate has been like basically manually expired, manually revoked by the CA. And you'll find that inside of the certificate here. When you go, it's under extensions, CRL distribution points. So this thing right here is the CRL for that particular CA. And in this case, it looks like the CA has multiple CRLs because otherwise that CRL would be really, really huge. Now, fun fact, in DoD, you have machine certificates and you have a CRL, right? So you run your own CA, and you have machine certificates, which works for VPNs and network admission control or network access control for Wi-Fi and 802.1x and all that stuff. There's a CRL there, and those usually get really huge because you've got all of these different machines that are getting added and removed from Active Directory and from the network. And so they have a fairly sizable CRL. Okay. That's why your machines won't boot up in the morning, because they can't get on the network until they download the CRL. All right. And then the last one is mutual TLS. Mutual TLS is where you have a certificate in the browser or whatever that endpoint is. It might be an email client, it might be something else, but that desktop computer identifies itself to a server or a network using a machine certificate or a local certificate or a local machine certificate. It'll identify itself. So instead of just identifying the server, you're identifying the server and you're identifying that endpoint or that browser. Okay. It's basically two-way verification. Cool. Everybody good? Thumbs up. If you're having a problem, raise your hand, ask questions. Awesomeness. Next one, exploring TLS and certificates on popular websites. So let's go look at some of these, right? So Disney.com. We're not going to do the whole list. Just go Disney.com, whack that guy. Connection is secure, certificate is valid. So you see, they use a certificate from Let's Encrypt. Let's Encrypt is awesome. Let's Encrypt is Google, Akamai was part of it, Cloudflare was part of it. A bunch of important websites got together and they said, look, we need to go to TLS everywhere. We need to be able to have Mike's Cat blog that has a valid TLS certificate there. In order to make that happen, let's team up. Let's build our own certificate authority, and let's have a way of validating that Mike owns Mike's Cat blog. And then if he does, let's issue him a certificate, short-term duration, so it's good for 30 days. But then I can put that on my web server for Mike's Cat blog, and it's free. It's absolutely free. You just have to script it out because you don't want to manually go get a new certificate every 30 days. Okay. So they built a software stack to help automate all this. It's awesome, but you'll see it a lot in CDNs where they have, like Cloudflare does it, Akamai supports it, Fastly supports it, Edgio supports it, where they'll automatically import that certificate from Let's Encrypt. Other fun things that you see here, details. Let's go down here to my favorites. So subject alternate names. You got a bunch of different buddies, cars, characters, embeds, Muppets. Certificate itself is okay. So the CN for this is www. So they didn't use a wildcard for the top. And so as a result, they have to actually list all of these subject alternative names on the certificate in order to make that certificate work for all these different websites. Okay, so questions. Disney.com redirects to Disney.fr, and Disney.fr certificate is Entrust. Does it actually work, Pierre? Or because Entrust got delisted from some browsers, if I remember correctly. It might break. So every once in a while, a CA gets in trouble and they get kicked out of the pool, and you can do it yourself. You can delist it with caveats, which is if you delist like Komodo, DigiCert, Let's Encrypt, then pretty much 75% of the web will break for you. Question here from Monty. How long has that been out? Let's Encrypt has been around, 7-8 years now. It's been around for a long, long, long time. I remember working on it and hearing about it way back before I moved to Singapore. So I moved to Singapore in 2015, and I think it's like 2013, 2014. Okay, couple others here. Amazon.com. Let's go. Okay, and then we click here. We go to connection is secure, certificate is valid. Here we go. So they use a www. All these people who don't give their organizational units, they're signed with DigiCert. Company just bought mine. And then let's go look at their SANs. Where are they at? Extensions. So object alternate names. Okay. So they did an interesting thing. So the actual certificate is for www, and then they have a SAN for Amazon.com. So if you have a certificate for www and somebody goes and you'll see, I went to Amazon.com, no www, that certificate will be invalid. So they have to go in and add Amazon.com. So the top of the domain, they have to add that to the certificate so that it's valid. And here's one. Here's my sports fans, Buckeye retail website, right? So Buckeye, keep scrolling on me. Buckeye retail website. So if you're a sports one, oh, there's testwww.amazon.com. Ooh, awesome. Conradtest.amazon.com. I'm curious what's there, but I won't do it now. Okay. Cool. So you can go explore these. Once you start exploring like 10 or 12 of these things, you're like, oh, okay. You get a feel for what sort of methods that people use to actually create their certificates and what values they typically put in there. Okay. And then the last part of session 1 is CA hierarchy and the browser CA keychain. So certificate authorities. I've talked a lot about certificate authorities already. So far, what we've seen is that certificate authorities sign X509 certificates, right? And you'll see it. So our Amazon.com here, you just see here, general, it is issued by is the CA. It's issued by DigiCert Global CA, Certificate Authority, G2. Yeah, I don't want to know what's it, test WW. By the way, that's one of my little penetration testing tips. So let's keep it quiet, just you, me, and the internet, okay? CAs actually pay to be in the browser store. There's a process they have to go through to get onboarded. They have a security requirements. They're usually really, really, really paranoid to the point where they make me look like a Pollyanna, like everything's happy. They normally take their CA code, their CA private key, they put it on a laptop, they lock that in a safe, they have 2-person controls when they sign something. It's very uncomfortable. And the reason why is you actually take and install, or the browser, your OS manufacturer does this, they install that CA certificate as part of the operating system. And they say, trust this. Okay, which should make you paranoid. They say, trust this. And then that CA signs certificates, and you actually trace the signature from the root CA, is what they're called, to usually an intermediate, and then to that certificate. And so if something happens to that root CA key, it's not really easy to replace that in everybody's operating systems. Okay. And so what they'll do is they'll take all that root CA that's in your browser or in your operating system, they'll keep that offline, and they'll use that intermediate CA to sign stuff. It's a lot easier to sign everything, and they can keep that certificate authority online. So CAs pay to be in your browser store. They usually have ultra long expiration dates, and you can look at these. And the intermediate CAs can be revoked. So because that intermediate CA isn't trusted in your browser, they can revoke it and sign a new intermediate CA and rotate that through. And that's how they deal with incidents. That way they can keep that online. Okay. So question here, which is distracting me because it's lengthy. Wouldn't it be less secure if wildcard, which is star.google.com versus www.google.com in a certificate, since it's all subdomains? Yes, that's a wildcard. If I can go create, miketest.google.com, that certificate will be valid for it. Okay. The certificate itself, not that big of a deal. Okay. Because it's public. You can see it in your browser. That certificate has a private key that goes with it. And if you have the private key and the certificate, then you can be any machine inside of that domain. Okay. Does that make sense? So you need to pair the two up and put those on a server in order for it to actually make the magic that is TLS work. But yes, so now the question here towards the end, let's see. How do you decide which one to use? I'm going to say the thing that'll make you laugh. It depends on your marketing people. Okay? Because they're typically running your website. And it's how you divide out your business units. So you'll see Disney here. Disney they push all their traffic. I'm trying to click and talk at the same time and failing miserably. They push all their traffic to www, but then they have branding down here under subject alternative name. They have cars, characters, Babel, Aja, eats.disney.com, right? And so they have a bunch of subsites that are under Disney. Now, there is sort of a soft limit on how many subject alternative names you can have inside of a certificate. And so once you reach a certain point, like 100, it's easier just to say, like, look, we can't manage this. This is impossible. The branding people are killing us because they want all of these different, FQDNs for different business units. So let's just do a wild card from there, right? And that's what Google does. That's why Google's certificate is a .star, is because they have, Drive and www and the top level, and they've got everything they make. They make a new FQDN inside of google.com, and now they have to support that with a certificate. Okay. Where Disney is a lot more controlled. Okay. Yeah, I think I answered that one. Okay. But yeah, it goes back to branding and like how your business is structured. And like if you're maybe a small company and you only have 3 websites, it's really easy. Just build a certificate for the top level and then have SANs for the 3 websites that you have. Done. Once that business starts to grow, it gets really, really weird. I went to a conference last month in New York City. It was Domain Dynamics. Basically, I met all of the people for all the media companies that buy certificates. And it really goes back to like, what are your trademarks? What are your registration? What is your intellectual property lawyers? How is your business structured? How do you organize your websites? Like, it is incredibly more complicated than I ever hoped to have to deal with. I'm like, look, just tell me what I want to put on the certificate and I'll make it work. Okay. This we've talked about. There is one interesting thing, which is some companies get intermediate CAs for internal use. And if you're an enterprise and you've got a lot of desktop users, laptops, you have 2 choices. One is you can go to a CA and you can get an intermediate cert that you then sign all of the certificates for your machine cert. Sign all this machine certs, right? Local machine certs. That works. Or you can create your own CA. You can use your own CA to sign all these machines. But then when you add a new machine to your enterprise or add it to your Active Directory domain or whatever, you have to install your root CA in every IT asset that you own. So sometimes it's easier just to buy one and have it signed. Now, there was a funny thing 5 years ago, 6 years ago, where the CAs came out and they said, hey guys, you're a penetration testing company. We issued you an intermediate CA, which is now valid, and you're using it to create certificates for Google.com, Amazon.com, and you're using that in penetration testing. You're basically creating certificates intentionally to do a machine in the middle attack as part of your testing. Could you please stop doing that, because it's basically breaking the fundamentals of privacy and security, just so you can have good penetration testing results. And so they came out and put out a bulletin that was like, could you please stop doing this? Another reason that you'd want an intermediate CA, back in the old days, I worked with some Blue Coat machines, and we did the same thing. We did a machine in the middle, right? It used to be called man in the middle, but we made it gender neutral, which is cool. And we would take our blue coat machines, there were proxies, and they had SSL accelerator cards. It was SSL at the time, it wasn't TLS yet. And we would put an intermediate CA on those blue coat machines so that when you went to, say, google.com, you would go to the blue coat machine. It would generate a certificate. It would use that intermediate CA to generate a certificate for google.com on the fly and present that to the browser so that they could basically machine in the middle every website on the internet. And so there's another, like, people do that today with proxies, but it's all for enterprise use. Occasionally, you'll find one of the countries that's really uptight about surveillance and they want to monitor all their people. They will do some stupid CA trick like that and intercept everybody's traffic. And then somebody's like, hey, wait a minute, the certificate is different from, it's not just one country. There are multiples out there that do it. They might use the acronym BRICS plus a couple others. They might also be called Axis of Evil in another time. But some of them do that more, less. But what you do is you look at the certificate you get, outside of that country, you compare those fingerprints and say, hey, I'm getting a different certificate that's signed by a different CA. Let's go look at that CA. Okay. Looking at our CA store, we're going to go into my workshop notes. So let's do this one. This one wasn't officially there, but on slides, but let's go do that. And give me a thing here. Here is a big command line. And what I'm going to do is I'm going to grab this. So curl can tell you a lot of stuff. It's got this -v flag. So curl is just a command line web client or HTTP client. -v will show you the TLS negotiation. -o, let me try this without, right? So where's my command line? It disappeared. Okay. So if I go, curl -v https:// google.com. Okay, cool. -v will tell me everything that happened, but it also spits back the page at me. So if I scroll up here, you'll actually see, oh, okay, I did a DNS resolution. I got some answers from DNS. I'm connecting to it on port 443. Oh, look, we got some options. Let's start our TLS handshake. Hey, I've got some root CA certificates. Remember that. We'll be there in a bit. We did our handshake using TLS version 1.3. We did our key exchange. We negotiated a cipher. We got a certificate from the web server. Here's our CNAME, our canonical name, which is google.com. Here's our certificate details. It's valid. This right here, SSL certificate, verify OK. Then, oh, look, we're using HTTP 2. Here is our HTTP request. And then we invalidate our session. So that's part of our perfect forward secrecy. And this is our response. Somewhere in here, we should have a HSTS, and I don't see it. There we go. Content security policy. So that's content security policy. I don't see an HSTS. And then here, where it says doc type, this is our HTML response that we got. But we had to scroll through all this stuff. So I do my little trick here, which is -o/devs. All right, fine. You're going to be that way. Reset. It worked my command line. So I'm just going to go back here and I say -o/dev/null. What that says is take the HTML file that this connection gives you and drop it in dev null. So just don't show it to standard out like you did before. And what that gives me is something like this, which is, if I can grab the corner there, which gives me just my negotiation. So here's all my TLS negotiation. And then it says, here's my HTTP request. Here's my HTTP response and a little bit data that says I saved to a file, but it doesn't show me that HTML junk because I'm just worried about the connection details. Okay. And so you can use this to verify anything. Now, or to verify anything, look at the connection details, look at the options, troubleshoot HTTP, have your way with it. Now, if there is an incorrect certificate there, you can use -- insecure to basically ignore TLS certificate validation. Okay. So just ignore it, carry on, still make the connection, still send your data. Cool. So I have to do that sometimes when I'm troubleshooting. I'm like, oh, okay, I'll add insecure because I don't have the right certificate loaded or something like that. Okay. Let me catch up on chat here. France interception. It's been talked about. How the US has talked about it. Hasn't happened. Maybe. Question from Jason, is that SSL interception or SSL inspection? It is neither of those. It is TLS intercept because they have a certificate that pretends to be, or that's valid for the website that you want to go to. SSL inspection or TLS inspection is when you are on the network, you can grab that certificate, that Diffie-Hellman exchange. You can grab that and grab the session key from that. There's a plugin built into Wireshark, and then you can decrypt all of that conversation after that. Okay. So don't we want to know when data is leaving the network over HTTPS? Yes, in enterprise sense. So you own the network, not a problem. It's a problem when, well, you have other issues, right? So like who's watching the watcher? Is your NOC spying on Mike's credit card information and writing it down and, making fraudulent purchases later? Yeah. The big issue is, by the way, I'm ripping my EFF today. The big issue is when countries do it because they want to spy on everybody in the country. Okay. And there's some kind of spectrum in between, right? What happens if my ISP does it? Or what happens if there's a court order and it's lawful intercept? Maybe there's a bunch of different what ifs and corner cases. But yes, countries want to be able to control, in some cases, what people are looking at. So you have to do machine in the middle if you want to inspect traffic. Yeah, and it's common in enterprises. You do what I did with the blue coats, where you have a proxy that does TLS man in the middle so that you can look and see you can actually see what URL and what query strings and what host names that Mike is going to, instead of looking at just like the layer 3, layer 4 information, which doesn't tell you much, right? You get like NetFlow data, which says somebody at this IP address made a connection on this port to here. When you do TLS termination, you can actually look at the full URL with query string. You can look at the HTTP post. You can do a lot more security things to determine if that communication was caused by malware or if it's data exfiltration. Or you could even do censorship of your user's traffic because you can actually see what website they're going to. One thing I forgot, which is inside of my HTTP request here. Okay, really, really simple request. There is this thing called a host header. That is, what is the fully qualified domain name of the server that I'm going to? Pro tip here is that has to match the CN or the SAN on the certificate. Otherwise, curl's going to throw an exception. It's going to complain at you. Lots of not safe for work words that I would use there. But it's basically going to complain. I tried to go to www.google.com. I got a certificate that was for something else. What are you doing? So I'm going to make an error here. I'm just going to do dig www.google.com. Boom. I get an answer. I'm going to, all right, copy. I'm going to do vi. This might be fun. Sudo vi etc hosts, password. There's nothing in there that's like really crazy. You can map out my home network. Ooh, yay. Insert, right click, paste, say test server.foo. So I basically took the IP address for Google and I told my operating system that that's test server.foo. Exit out of there. Now I can do curl. I'm intentionally creating an error here. Okay. I'm intentionally creating an error here because I'm going to go to Google and watch. Right. So I went there. Oh, Etsy hosts told me that test server.foo is there. Here's my handshake. I got a certificate. The CN is www.google.com. That is not the same as the HTTP host header that I'm looking for, the website that I'm looking for. And basically it said subject alternative name does not match test server.foo. No alternatives, subject name. Basically, this is where SSL says, hey, don't fail. Don't connect there. And then it closes the connection and it says, yeah, I got an error. I got error code 60. Okay. Now, if I go back up and I say insecure, ignore the TLS certificate. Oh, and there I negotiated. I sent my request. I got a response. Everything works normally. Cool. All right. Ooh. And then the next thing we want to do, this is here. So that was all this via the TLS handshake. View your root CAs. So inside of Linux, they are in etc. SSL certs. So if I just go sudo -i ls etc. Where am I at? Oh, etc. SSL. Again, SSL. Okay. So you'll see all of these certificates that are here. These are root certificates from the CA. Okay. In Mac OS, you go into applications and then there's a folder inside of that called utilities. And then there's something there called keychain access. You open that up and you look for trusted CAs. That'll show everything to you. In a Windows world, I've got a Windows here and you go to cert mgr.msc. Okay, cert mgr.msc, that pulls this thing up. You can hit that, right? And it will show you all of the certificates, trusted roots, certification authorities, certificates, and you'll have all of these. And you'll notice, like, there are quite a few of these. You'll see in here, there should be like a Google, was it W2? You'll see like the DigiCert ones. DigiCert has a bunch of these. You can actually click here and see the certificate details. So the same exact thing, right? Like what's the expiration date? What's the organization? All of that. Here's a certification path. So you can see that. You can also go in here and like revoke these. So this is Landsweeper. You can delete it and then it goes away. This was all the rage like 10 years ago. People would go in here and they delete. They're like, who's this Komodo, right? So if you delete Komodo or if you delete DigiCert, the web stops working. It's pretty crazy. These are, you'll see the name here. These are trusted root certification authorities. They're basically certificates that you import into the operating system. You just literally write it to the disk and you say, oh yeah, right click, import it and trust it. And it adds it to the list. And now any certificate that's signed by that CA will be valid. It'll verify as valid. Questions here. How valid cert can validate if the site server it is. Yep. Okay. There's nothing for me to comment on, Jason. He's adding content, adding color. Cool. So that's it. So you have all these CAs that are here. Was there one other thing? Oh yeah. And now you can also have for mutual TLS, you can have machine certificates. So if you go in here and you go, pull that up. Yes. I get my UIC. So this has more. So I still have like trusted root CAs, but this one has like personal certificates. Like I've got a couple that are there that show up. Just cert LM gives you all of the local machine certificates also. So you can look and see if you're doing like X5 802.1x network admission control, or you're doing some enterprise controls, you'll have certificates that will show up here. On the Linux side, they started a funky place. It's etc SSL private, and there's actually one that's there. There's actually a certificate there that's snake oil. That's a key. So it's a key. No, that's an OpenSSH private key. So that's there as the machine key when you SSH into it. But that's where you can store your machine certificates that you use for mutual TLS. Okay. I'm going to move this guy over, this guy, and you can read these. I've got this a little bit lower. You can do OpenSSH X509. So if we go up, LS, okay. I'm just going to pick one here and I'm going to read it. But you run open SSL command line 09, which is the module to read a certificate. Dash in, I'm going to pick one, XRAM, right? Dash text. So give me the output in text. Don't give it to me in binary. And dash no out says don't write it to a file. Okay. Like I said at the beginning of this is not a comfortable command line, okay? And I run that, and it'll spit it out, right? So it spits out all the details that we're used to seeing. So here's the organizational unit. Here's the friendly name of the organization. Here's the CN, the sub-organization. The subject here, the C, there you go. OU is xrampsecurity.com. All of the, different algorithms and things. And then here's the actual signature. And then this is the public key right here. Let's get back on track here. So certificate creation process. How does all of this stuff happen? There's a workflow. Okay. It looks like this. So you go to your server and you create a private key. And it's really straightforward command line, create a private key. Then you create something called a CSR. Think of it as that wrapper around that private key or derived from the private key. But it has all of that information that shows up on the certificate that's human readable. And it creates a fingerprint for that private key so that it can be signed, right? Because when you sign a certificate, you sign the entire certificate, and then you sign the private key. And so it adds that to that CSR. You take the CSR and you submit it to the CA. The CA verifies that you are you. And this is the funniest thing to me ever. Back in the old days, so back in 2000, 2001, 2002, when you wanted a signed CSR, you would generate your CSR on your server, you would export it, you would sometimes email it to the CA, you would take the fingerprint of it, and you would write on company letterhead, like, hi, I am Mike Smith, and I work for Mike's Cat Blog, and I would like to verify this CSR. Here's the fingerprint of it. Here's the common name and the SANS. At that time, we might not have even had SANS yet. But here are the details. Please sign it. And you would take this, print it on company letterhead, sign it, and you would fax it to the CA. And they said, good enough. And they would sign it and give you back the signed CSR. It's really funny because you would just fax it. And so they were relying on the fact that you knew the fingerprint and you had company letterhead, that yes, you were part of that company. We hopefully don't do that anymore. They added this extra process called extended validation, which is they would call you and say, hey, is this Mike? And you would say yes. And they would ask you some questions, and then they would say, okay, it's you. You actually submitted the CSR, and then they would sign it. Seems very quaint today. But that's how we used to do it. Today, if you go to, say, Let's Encrypt, Let's Encrypt does this thing where you can validate by either making a DNS entry, and I'll show you what the Verkara one looks like. So if you do dig-t text verkara.com, you'll see it will be, it's like one of these things, but basically you make a text record, and I don't see it outright, but you make a text record that has a token in it. You use a client like CertBot or Lego that creates the private key, creates the CSR, says, hey, you need to create this DNS entry. You make a text record for the domain with that entry. The software submits it to the Let's Encrypt CA. Let's Encrypt checks to see if that DNS text record is there. If that text record is there, then it signs the CSR and gives it back to you. And it's all automated, which is awesome. Awesome stuff. But that's called domain validation. There's another version where you go and you put an object on your web server. You make a text file in a particular location, a particular path that has that token value. They check to see if they can load that particular page or that text object. If they can, then they say, well, you obviously own the website because you were able to put that text file there. That's called web verification or HTTP verification. Okay. Really, each CA has their own policy on how they verify that you actually own that domain or that website. Sometimes it's just you're a customer and they've known you for years. They have zero problems with it. Sometimes you need an email address of the domain. Sometimes they create user accounts. So you have to log into the portal. And so that's considered validation. There's a bunch of different steps that they have to do, but they all have a different policy. So a question from Derek, which is something in the HTML header or footer? No. Let's see. Do I have one of these? You'll just have to go, let's encrypt HTTP validation, right? So challenge types, they actually give an example here. There's a DNS challenge. So shift control. So it is like this. It's, mikescatblog.com, well-known Acme challenge. They give you a particular token, and then they give you a value inside of that. They give you a particular value inside of that. So this is like it's similar to an MD5 sum or a base 64 encoding for the path. And then inside of that, it's just an ASCII text file. And then inside of that, you have another base 64 value or something similar. I'm not quite sure on the exact encoding. Please fact check before you do anything crazy with it. So then once the CA signs the CSR, they give it back to you for some way. A lot of times you just go to the portal and you download it, and then you pair that CSR or that signed certificate. It's no longer a CSR. You pair that certificate up with the private key. Their private key is probably still on your web server. So you just take that signed certificate and put it there and add that to the configuration for that web server. A variant of this, so for example, if you use Cloudflare, any one of the CDNs or some other service providers, they have a facility where you go in and you say, I'd like to make a certificate. They're like, okay, cool, no problem. Could you go make a DNS entry for this? I'm going to try one thing. dig.cat, hosts, evilsite. I think. Don't go to this, by the way. Do not go to evilserver.com. No, that's not it. I'm trying to do crazy stuff on the fly. I actually have a server that I host malware on for demos, but in order to make TLS work, I had to get a TLS certificate. So I had to make my domain validation. A lot of CDN service providers, what they do is the private key resides on their platform. So they just have all the automation. You say, oh yeah, I'd like to have it for this host name. They generate the private key, generate the CSR, export it to the CA. Then they ask you to make a DNS text entry. And then when it's there, they check it and say, yeah, okay, that's there. And then they re-import the certificate back in and just pair it up. So you never actually handle things directly. It's just all through the web UI and the configuration UI. Okay. Let's see if I have it for edgeo.app. Forget if I did this or not. This might fail out. This might bomb out on me, guys. And they might have kicked me out. They might have kicked my stuff off. Okay, web properties, Borg, web properties, Fusite, deployments, production. No, I'm not going to mess with that today. But Edgeo is another CDN, and they do it that way. Don't go to evil server. Don't go to evil server because you will get ransomware. So let's see. I think it's like a reg edit entry, but in domain structure form. Yeah, it's similar to a reg edit, but it's stored in DNS as a text record. Okay. Or on the web server. Okay. Back on track here. So whiteboard, which I think we don't need to do. We'll get there. So let's go create our own CA. This is where you're going to need a Linux command line. So this is our step or a process. Create a private key for your CA. Create a certificate for the CA private key. Okay, so that's called the self-signed certificate, which is basically there's no CA to sign it. So you just say, oh yeah, this is me. I'm there. And that's what the CAs do. They basically say, hey, this is me. It's our certificate. Sometimes they'll actually sign each other's certificates, which gets weird because you got one CA signs another CA. And sometimes the vulnerability scanners got stupid about it. You then create a private key for your certificate. So for your web server, and then you create a certificate for your web server. And then we're going to go deploy it to our own web server. But let us get to a virtual machine here because I'm going to do this. And there are instructions in here so you can follow along at home. So I want to log in here. My password is password. Okay. And I want a sudo-i. Sudo-i. It's just like sudo, except it's like su. It's like su to root. It keeps it interactive. It doesn't just run one command and done. So that way you don't have to write sudo every single time. I'm old school Linux, so I used to su to everything. That's what we're doing. So here I am. Now, I just want to make go like this, move this over so I can copy myself. Why? Because I've been doing this for years and years and years. I still use a cheat sheet. There is no shame in that because this is eclectic stuff. Okay. Now, I want to grab some stuff. So I want to sudo, I'm already there, apt-get install CA certificates. Okay. I already have it there. That actually is the list of all the CA certificates. We looked, they're there. We don't have to mess with that. I want to make a directory, call it whatever, PKI Stukas, CD, PKI Stukas, LS, boom, surprise, there's nothing there. I just made the directory. Okay. And then I want to create key. And so we're open SSL, gen RSA. RSA is asymmetric cryptography. It's Reves Shamir Adelman. It's an asymmetric cryptography algorithm. And we're going to use gen RSA, which is a module inside of OpenSSL that creates a key pair. Okay. And I'm moving you guys over so I can actually see chat here. So OpenSSL, gen RSA, dash out, my ca.key. You can call it whatever you want, but you will confuse your, okay? Because you got to keep like ducks straight. This is also another way that you can introduce problems. If you got a lot of keys sitting around, you're like, what did I use? Which one did I use? Why did I use this? Like, you will confuse yourself. Okay. My ca.key, and then 2048, which is how many bits do we want to make this? So we want to make a 2048 bit key. If you want to be paranoid, you can do 4096. Don't worry about it. Just use 2048. So that's done. I do ls. Oh, look, I've got my ca.key file, my ca.key. Oh, look, it's ASCII text. Cat, my ca.key. Right. And so it says up here, begin private key, end private key. And it's got a lot of gobbledygook, which is what we call ASCII armor. It's ASCII armored. Okay. Which means that it's a text file. You can actually go and take that and turn it into binary, like decode it and all that stuff. And it's all good. Now we got to run the next command, which is here, which is open SSL rec q is to make a CSR. certificate signing request. REQ is request in OpenS's. And we're going to make an X509. Shouldn't be a surprise there what that does. It makes an X509 certificate. Dash new. So we want to make a new one. We don't want to modify one that's already existing. A dash nodes, which is we want to add all the bits and pieces to it. Dash key. What's the key that we're going to make it from? CA.key. The dash nodes actually signs it. We want to sign it using SHA-2, which is that hashing algorithm. Okay, so that's that hashing algorithm that we're going to use to make the signature. Dash days. I'm going to run out of room here. 2-5, which might just happen to be either like 5 or 10 years. But fact check. Just 365. 365 times something. It's how many days is that going to be valid for? And then dash out. My CA dot, I believe PEM is what I wanted to put it in. Okay, right. So it wraps around, but you guys see it's all there. Dot PEM is a dot PEM is a format for keys and a format for certificates. Okay, and now we get to all the questions. This is part of the CSR. This is all the data that ends up on that certificate, right? So the country name, U.S., state or province name, FU state, locality, city, FU city, organization name, Mike's Cat Blog. Organizational unit name, CA division, common name. So that is what we want to call it. You'll see it actually prompts you and says server FQDN. Server FQDN, which is fully qualified domain name or a host name. I want to call it ca.mikescatblog.com. By the way, I use Mike's Cat Blog forever and ever and ever as an example, and then I wrote it down once and it made me laugh. Give me a thumbs up if you get the joke. Email address, raylove@mikescatblog.com. Don't use your personal email address in certificates because it's publicly available. So all the spammers will start sending you stuff. Use like CA, right? CA@mikescatblog.com. Right? Use a drop email address so that you can share it across the team and, be smart with it because it's publicly available. And there you go. It generates it. So it takes that private key. It generates the public key. It generates the CSR from the public key. It signs it and it spits it out. So if I do an LS here, I've got myca.pem. So I can do file myca.pem. It says, oh, it's a PEM certificate. By the way, note that I used small ca. I violated my instructions here, which will break me later when I need to use it. So I'm going to do move my ca.pem to my ca.pem. Okay. Now you can read that if you do open SSL X509. So we're going to use the X509 certificate reading authority or utility -in my ca.pem -text. So give me a human readable text output and -no out. I don't need to write the output to any file. And there you go. Cool. And if I can't scroll up quite less. Okay. So you'll see here is my issuer. All the issuer data is there. Email address, my division name, my subject has the right fully qualified domain name there. Here is my public key. Here's my signature. And I've created a root certificate. Cool. So just a quick check here. Is anybody having problems? Need me to redo any part of that? Are we good? Okay, let me check. I had a question here, question from Ani, which is, I used 1825. What should be the max in the real world cybersecurity application? crazy question because you get the security guy answer. It depends. And what it depends on is what's your risk assessment, right? So for a certificate authority, a lot of those will be a longer period of time. We can actually go do a survey here. You'll see AAA. So this one is good from 2003 to 2028. So that's 25 years. Let's try like some DigiCert ones. This is from 2006 to 2031. So 25 years. Same 25 years. By the way, these were also signed in 2006. That is a long time. This one's 2013 to 2038. So yeah. So these are 25 years, right? These are public CAs. That's typical for a CA, right? Like CAs are 10 years at a minimum because it's going to take them a year to get it put into all of the browsers around the world and all the operating systems around the world. And they don't want to have to go through that pain again. SSL certificates or TLS certificates or X509 certificates for a particular web server, we used to get them for 10 years and then it was 5 years and then it was 1 year. If you're getting it from a regular CA, 1 year is about normal. It's very rare nowadays to get a 2-year certificate. Let's Encrypt. A lot of the CAs for, like little websites, they now have an expiration of like 90 days or a life cycle of 90 days. It was one of the things that we learned during Heartbleed. There was a vulnerability in OpenSSL that could have exposed the keys for TLS certificates. And as a result, we changed as an industry. So that was 2014, if I remember correctly. Might have been 2013, but I think it was 2014. And the life cycle for certificates started to get smaller and smaller and smaller, because if there's a vulnerability in that software, that reduces your exposure. It reduces your risk. But like squeezing a balloon problem, it makes it so that compromise of a private key for your certificate isn't that big of a deal because they only have 90 days to go be evil with it. It also means that every 90 days, you have to go rotate certificates. And so that causes operational problems, system management problems. If you're an enterprise and you have a lot of certificates because you have machine certificates and you have 10,000 machines, can you rotate 10,000 certificates in a month? Probably not, right? But then again, what's the life cycle of an average machine, right? So like somebody's laptop, they're going to have that laptop for 3 to 5 years. Maybe you want to do that yearly or every 2 years. Maybe you want to create a machine certificate and make it last for 3. And then at 3 years, maybe you decom the hardware. You have some decisions to make. As far as like that trade-off between paranoia and usability and workload. Okay. That was one of the problems that content delivery networks had. So they have lots of certificates. And then when Heartbleed came out, they had to go through and they had to rotate all of these certificates. That doesn't happen overnight. That took a while simply because the CAs couldn't issue them and, sign them at that rate. And so we changed as an industry. TLS itself changed, policies changed, and that life cycle keeps getting shorter. So questions, let's see, into chat. 2014, I was right. Yes, I like being right. It's okay to use a wildcard cert on a couple hundred servers with the same expiration date. Maybe. InfoSec answer, it depends. It depends. Is this internal use? Is this external use? Is it like, are you putting regulated data there? Do you have jerks for auditors? Do you trust your system administration team? There's a lot of questions there. You have to look and do a lot of threat modeling. Okay. We've got 13 minutes. Let's get shorter, faster, funnier. And make a certificate and then stick it on our server, and then we will be at time. Okay, and we'll keep getting some pop-ups here. So generate a certificate using your CA. So what I want to do is make a web server key. So open SSL gen RSA. So make that RSA key pair -out web server.key 2048 bits. Boom. Done. LS there. Oh, look, there it is. Whoops. Move web. I've misspelled key. Web server.key. Web.key. Cool. There it is. Oops. Oh my God. LS. Cool. Now I create a new CSR. Open SSL rec. So make it CSR request -new -key from that web server key -out web server.csr. It's going to ask me all the questions. Most of these you can return through, but you do have to fill out the common name, blog.mikescatblog.com. You can add a challenge password, probably the best to do it. I'm not going to here. Optional, you can add a company name. Done, right? So LS, and it makes that CSR. I can do file web CSR. It's a PEM certificate request. I can actually spit that out using the same OpenSSL X509, So that'll give me all the details. It'll be the same as the certificate. And then I want to sign it using my CA. So I will do OpenSSL X509. So use the certificate module. We're going to import a CSR or request -in web server.csr -ca. So what CA private key are we using? My CA.pem. That's the CA certificate -CA, which looks like K key. I know that. It's the CA key, which is going to be my CA.key. So use that CA private key to actually sign it. I have one thing, which is CA. I have to move this over. Hang on so I can see it. -CA create serial. So make that make the serial number for that certificate based on the next in the row for the CA -out web server.pem -365. It will have a validity for a year, and use the SHA-2 algorithm for the signature. Yep. What did I do wrong? Rick X509 CA key, CA create serial out. I think I blew it up. I might have done something wrong. Let's see. CA create serial rack in X509 rack in web server.csr. I probably listed something incorrectly. CA create serial out. That should work. I just blew it up, guys. Make sure I got a Q there. It's 509 in there -CA. It might be cert. Nope. I blew up. This is the other fun thing about working with command line OpenSSL is it is not friendly. It is not friendly. CA key is bad. Is it CA key? Yep, you're right. CA key. What? I still blew it up. All right. I'll have to go check my magic thing here. Did I really mess it up that badly? Let me check my notes. Trust me, I'm a professional. Okay. -CA key. Oh, that's why. I didn't fix my CA cert. Haha. Okay. So that works. So the problem is I had CA key is capital C, capital A, and then I fixed it, but I added CA cert where it should be just -CA. Cool. And so I do LS there. There is my web server.pem. and I can do open SSL x509-in web server.pem dash text dash no out. And there's all my certificate in all of its fun and funky glory. All right. Now, let me check here. Yeah, the live demo gods. I forgot to sacrifice my rum and chicken to Jobu, the live demo gods. That's why I was jinxed. Now, in order to get to, I'm going to leave this here and then I'm going to open it up for questions. Here inside of my notes, you can use the certificate in Apache. So here what I'm doing is I'm installing Apache. So that installs the Apache web server. There is a module called SSL, again, SSL, for Apache that turns on encryption. And A2EN mod is Apache 2 enable module. So that basically adds the library into Apache so that it can understand TLS. You then enable the site, the default website for TLS for Apache. Then you edit this configuration file and you want to replace the web server that's there, which is like the default snake oil certificate. You want to replace that with the actual certificate and private key for that you just created. And then you want to restart Apache 2 and it will pop up and you should be able to view your certificate there. Okay, cool. And that's how you deploy it. You can do the same thing. You can do the same thing else, like with email servers, with LDAP servers. It's the same kind of process. You create your certificate, you put it someplace that the server daemon can run. You configure the server daemon where is the private key and the certificate, restart it, and it should come up with the right certificate. The last thing that I want to leave everybody with is this thing right here, which is SSL Labs. SSL Labs, again with the SSL, but think of it as a vulnerability scanner for TLS configurations. And we can grab one of these, like IA down, Secure Onyx. You just give it a website. It connects. It will actually go in and check the certificate, the expiration date, all of the cipher suites. What does that Diffie-Hellman key exchange look like? Does the server allow renegotiation? Is the certificate signed strong enough, using a strong enough algorithm? Like all of that stuff. It'll check it all, and then it will give you results and a letter grade. What most people do is when you build a new web server, you go to SSL Labs, you put in your website, you go scan it, and then you just fix things that are in red until SSL Labs gives you a score of A or A+. And then you're okay. All right. But that's how most people do it. In fact, most auditors out there, they just run SSL Labs. They get a report and they come back and say, well, you need to go fix these things. Just run it yourself, fix stuff. But because TLS standards change over time, you have to keep rescanning it and fixing things, because after 6 months, you'll have things that you have to change, new things that you have to fix, new things to take out of your configuration, new things to add. All right. Having said all of that, we are at time. Thank you, everybody. If you have questions, comments, war stories, you can get a hold of me. You can find me on Slack. You can find me on the interweb. You can message me here in the, where are we at? Ring Central. Get a hold of me. My nickname is Rybolov, RYBOLOV. You can find me on the interwebs. Put up the bat phone. I will help you out. Thanks, everybody, and have a good day.